Hello, beautiful people, and welcome to 8.2 and 8.3 notes. Hopefully you've done the warm-up. If not, go ahead and press pause so you can make sure that you can do these problems because they'll be helpful. But today we're going to talk about multiplying and factoring. So for 8.2, our SWABAT is to multiply a monomial by a polynomial, and we're also going to be factoring a monomial from a polynomial. Wonderful amount of words to try to say. So first thing, just to check your work after you distribute, this is what you would get, and then now that we know about standard form, we're going to write it in order from the highest exponent to the lowest. So if you didn't do that already, go ahead and fix that for me, please, or actually just take it one more step further. Number 2, 6m squared minus 27m, and then number 3, check your work with mine, negative 6y cubed plus 8y squared, and then minus 10y. If you're all good with that, then we shall proceed. So vocabulary, GCF, greatest common factor. This is the largest factor that goes into all of the terms. The greatest common factor, the largest one that goes into all the terms. So for our first example, they ask us to find the GCF of the terms for each polynomial. So I like to look at the numbers first, and I'm looking at 10 and 15. I'm looking at 10 and 15. What's the largest number that goes into 15 and 10? 5. The x, this one has an x, but this one doesn't, so they don't have that in common, so I'm not going to include that as well. The only two things that these two terms have in common is a 5. Okay, now looking at b, I have negative 2m cubed plus 10m squared minus 6m. This is where things get a little bit tricky because we say find the GCF, but truthfully speaking, if your leading coefficient is negative, you're going to be claiming the GCF is a negative because we're going to factor out this negative so that we can always start on a positive note. I'll get more to that in just a little bit. So because it starts with a negative number, it is in standard form. I'm going to write the negative first, and then I'm looking at the numbers first. 2, 10, and 6. What can I divide 2, 10, and 6 by? 2. Negative 2. Because the leading coefficient is negative, this will be negative. Then I look at the m's. I have 3 here, m cubed. I have 2 here, and I have 1 here. So when they're looking for the common one, we want to know what's the greatest one that we can take out. So they all have an m. But how much can I take out of all of them? The max, because it's to the first power, is just 1. I can't take out m cubed because they don't all have that much. All right. So that's that. Now that we know how to identify it, we're going to factor it out. So I'm looking at the numbers again first. What's your greatest number that goes into 9, 15, and 12? If you said 3, you are correct. Now they all have x's. The first term has 6 x's, the second term has 4, and the last one has 2. So what's the maximum I can take out of all of them? Well, 6, 4, and 2. The max would be 2. So it's kind of like you're taking out the smallest exponent, basically. Because if you're thinking about this, think about it this way. Let's say you all wanted to buy me a gift. I know, it's likely. Someone has $6, someone has $4, and the other person has $2. What's the maximum that you can all give in order that you all have contributed evenly? $2. You can all get me $2. So all three of you can put your money together and get me a $6 gift card to, I don't know, Starbucks, Jamba Juice, something like that. That's not a hint. I'm just using it as an example. Okay, so now we talk about the leftovers. So I factored out 3x squared from each of these terms. So here's what we're doing in our head. We had 9x to the 6th, and we're taking out 3x squared. It's like we're dividing it. 3 goes into 9 3 times, and then for this, I'm going to subtract the exponents. So I have x to the 4th left over. You can check it. 3 times 3 is 9, check. And then x squared times x to the 4th, I would add those exponents and get x to the 6th power. Okay, this next sign is plus, so plus 15 x to the 4th, this is what's going on in my head, divided by 3x squared. 15 divided by 3 is 5. I still have some x's left over because 4, I only took off 2, so I'm only subtracting 2 from this 4. So x squared is left. Plus, then you're going to divide 12 by 3x squared. I'm sorry, 12x squared. 3 goes into 12 4 times. I close my parentheses. Why? Because these x's cancel out, like 2 minus 2, 0. There's no x's left for this 4. That's your final answer for that one. Okay, do you want to try the next one? Let me start you off with the GCF first. This one right here, I'm looking at it, starts with a negative number. It is in standard form, which is nice. So I'm going to take out a negative number. Negative what? What goes in a 6, 18, and 12? 6, not 2, not 3, but 6. And then I'm looking at this, x to the fourth, x cubed, and x squared. What's the maximum number? Still 2. Still $2 y'all are getting. Leftovers. Try it and see if you can put your leftovers in parentheses. Negative 6 divided by negative 6, so that's just 1, so I don't really need that. Let's show my work for at least this one. X to the fourth divided by negative 6, x squared. These cancel because negative 6 divided by negative 6 is 1. And then I'm going to subtract my exponents here. So all I have is x squared. I still don't want you to put the 1 x squared there. It's just not a good look. And then I'm going to also divide negative 18 x cubed divided by negative 6x squared. Negative divided by negative, that's positive. 18 divided by 6 is a positive 3. X cubed divided by x squared is x. And then you have one more term. Negative, so this is what I'm doing. I'm dividing this by this. Negative 12 divided by negative 6 is positive 2. I took out all the x squared, so that's all that's left. There you go. Okay. Next. Write in standard form. Here's what would be great. Press pause, distribute, and then combine like terms for me. And then I'll put your the answer up in just 1 second. So press pause. Okay, what did we do? I distributed the 3m, and I had 15m cubed minus 6m. When I distributed, and then for these two, when I combined them, when I combined them, I have negative 7m squared. There aren't any like terms because none of these variables have the same exponent. So to put it in standard form, I wrote 15m cubed minus 7m minus 6m, and that's my final answer. Go ahead, press pause for just a minute, look through your notes, and then make sure that you're okay. If you have any questions from it, go ahead and write those there. If there's anything where you're like, not so sure, this way you'll remember to check in with me in our next class. So today's next lesson is to multiply binomials. We're going to multiply two binomials, or we might multiply a binomial by a trinomial. I'm going to give you 3 different methods for how to multiply these binomials. And I want you to try them using my specific methods first, and then you can eventually pick the one that you like the bestest in the whole wide world. But first, try them all. Take a little sample. This is like a sampler plate, and then you can choose whichever one you want to stick with, whichever one you want to put a ring on it and make a commitment to. So multiplying. The first method I'm going to show you is the distributive property, and that's where we look at the first term and we basically distribute it to all of the other ones. So this positive 2r, I'm going to distribute here and here. So 2r times r is 2r squared. 2r times 3, positive 3. Then you're going to look at the next term, which is negative 5, and I'm going to distribute that as well. Negative 5 times r. Ooh, I forgot my r. Dang it. That was a 2. Oh, I did not distribute that right. Just kidding. The magic of erasers. My bad. This is 2r times r was 2r squared. 2r times 3 is 6r. Let's get that right. And then negative 5 times r is negative 5r. And then negative 5 times 3, negative 15. From here, kind of like the last problem we did on that previous part, we're just going to combine our like terms. So 2r squared has nothing in common. These two do. So 6r minus 5r leaves me with 1r. I'm not going to put the 1 in front because it's not a good look. So plus r and then minus 15. Okay, that's the distributive property. Let's try it again, but now we're going to use it using a binomial times a trinomial. So I'm taking this first term. 4g times 2g squared is 8g cubed. 4g times negative 7g is negative 28g. 4g times 3, 12g. It's kind of nice and organized if you do it this way, if you're using two different colors. Then you're going to take the 5. 5 times 2g squared is positive 10g squared. 5 times negative 7g, negative 35g. And then 5 times 3 plus 15. Last step, combine your like terms. So 8g cubed had nothing. I think this was squared. Boom, boom. Yeah, this was squared. Sorry, guys. So then these two I'll combine. Negative 28 plus 10 is negative 18g squared. And then I have 12g and negative 35g. That's a negative 23, I'm thinking in my head. 23g. And then finally that plus 15. That's the distributive method. You distribute each term into the other. The next one, box method, I kind of love this one because it's kind of, I don't know, if you have biology and you do Punnett squares, you might hate Punnett squares then, but I think you'll like them this way, I hope. Give me a shot. So here's what we're going to do. We're going to make a box. There's two terms here. You have 5h minus 3, and then you have two terms here, h and 7. So for those two terms and for those two terms. Now we're just going to multiply 5h times h. 5h here times this h gives me 5h squared. Negative 3 times h is negative 3h. 5h times 7 will go here, which is 35h. And then 7 times negative 3 is negative 21. Like terms, what I like about this is they're always going to be on the diagonal. I was going to highlight, but I think it's going to block everything out. Always going to be on your diagonal. So right here. Looks like a peanut, I know. And I get 5h squared. 35h minus 3h gives me positive 32h. And then lastly, minus 21. Put a box around it. Okay, I'm going to give you the setup for this next box. One thing I'm going to tell you, it doesn't matter, like if you just make this 2x squared here and then 2x, I just don't know if I have enough room to go that far. So it doesn't matter for that. And then I have plus 2x, and then I have minus 6. Going down, you have 3x minus 4. Boom, boom. Okay, so there's your box. Take a moment and press pause to fill it. I'm going to fill mine, and then I'll show you what my result is. Did you get it? Did you get it? I got 6x cubed, 6x squared, and negative 18x. And then I have negative 8x squared, negative 8x, and then 24. All right, so I did tell you that your like terms were going to be on the diagonals, and they still are. So here are like terms, and here are like terms as well. So this one didn't have anything, so I'm just going to rewrite it. 6x cubed. Now, negative 8x squared plus 6x squared gives me negative 2x squared. Negative 8 plus negative 18 is negative 26x. And then lastly, I have positive 24. Check yours with mine and make sure that we match. I'm going to press pause here. You can look through these notes, and then video number 2 will go over the FOIL method, which I believe many of you have seen or at least heard of, which is why I didn't want to do that method first, because I should teach you something different first. So go ahead, check your notes, and then we'll do part 2 in just a moment.